page 191, and we are discussing the mesolimbic dopamine system. And the question we left y'all with was, is alcoholism inherited? We had some no's and we had some What's our general consensus of the class? Who says that a gene for alcoholism could possibly be inherited? Who agrees with that possibility? Okay, nobody. Oh, we got one. Thank you.
I think there's a gene for addiction, but not maybe to something specific.
They're saying alcoholism.
I'm just saying that there can be a gene for having more of an addiction type
Well,
personality.
so instead of a gene for alcoholism, we've got a gene for addictions. Okay, well, let me ask this. And you don't have to answer if you don't want to, but who has drank some form of alcohol? All right. The next question is, did you like it to the point you wanted to drink more often? Curly? She's back there going.
She's not even of age.
Yes, I am. I'm 22.
I'm
Because
shocked.
that stops
She's an
everybody
old
from drinking.
woman. So, most of y'all didn't think that highly of the alcohol that you drank. It was one of those, okay, I drank a little, no big deal. Didn't feel like you had to go back to it. Does anybody have alcoholism in your family history that you know of? Okay. And that's sad, but we all probably have had some alcoholism in the family history somewhere, especially if we go back to Indians. They like their fire water. Most of us probably have a little Indian heritage somewhere in our background, somewhere. And they may have brewed their own, who knows? Okay, so what, if there's not a gene, and that's what y'all saying, if there's not a gene for alcoholism, what creates this addiction? And I have a lot of classes, when I ask those questions, they'll say, I really like the taste of it. And I have no problem picking it up and drinking it whenever I get the craving. So they actually have a craving, which to me is an addiction. What creates that?
Maybe the senses learn and create something that causes someone to want to drink or want to overindulge in something. Maybe the sensations they get from watching all this creates something in us that gives us a desire to do that.
Wouldn't it be the same thing if you simply just like the taste of it, the same for you like the taste of anything else?
It could
Like you
be.
like Mexican food, so you're gonna eat that a lot, or you cook it. You like
Pizza.
Which goes,
cheeseburgers.
Yeah.
which goes
Pizza.
back to a gene of addiction.
Well,
People
she's
like
tooting
the
her own
effects,
horn
you
up
know.
here. A gene of addiction. Would you agree that some people have personalities that's more addictive personalities than
Yes.
others?
yeah.
Is that what you've been saying this whole time? I wish you had clarified that.
My answers are pathetic.
So, addictive personalities must probably play a role in it somewhere. What about just choices? I mean, did somebody hold you at gunpoint and say, drink that alcohol the first time you drank some alcohol? Maybe it was,
Happened to me.
it was
Just
a,
kidding.
do what? I didn't catch
I
that.
said that happened to me once.
Maybe it was just
Water guns don't count.
a friend, water guns. Maybe it was just a friendly thing where 3 or 4 of y'all gathered up and was drinking something, or maybe you was out eating, maybe it's just a glass of wine somewhere, who knows? But you made a choice to drink that first one. Now in y'all's case, you didn't particularly care for it that much, so it's not that big a deal if you ever drink again. But there's a lot of people, it is a big deal. They made that first choice to drink, and they liked it. I'm gonna give you some more of that, right? The next thing you know, more and more. Maybe that's the addictive personality, but it started with a choice, didn't it? So a lot of people say that if they have like they grew up maybe with a parent or a grandparent that was an alcoholic, and they watched that their whole life and they absolutely hated what they saw, and that turned them away from it. And so they made choices to just remove themselves from alcohol because they had the fear that they possibly would like it too. In some cases, they drank it and did like it, and it scared the far out of them because they saw, you know, so you could see that picture. But then some people use it for an excuse. Oh, my grandpa was an alcoholic, my dad was an alcoholic, so why not me? Why break the tradition? What a way to look at it. But some do that. They use it for excuse to be a slug in society like dad and grandpa probably was. But, you know, at the same time, there's a lot of alcoholics that have good jobs and are good workers, and they can hide it just like any other addiction out there that people hide. It's amazing how they can get up the next morning, probably got the biggest hangover in the world, and still function at work. It just blows me away that they have that capability, but they can. So not all alcoholics are slugs. They're actually pretty functional in society, a lot of them are. So the bottom line on this is we really don't know. With alcoholism gene, I kind of agree with you. I don't know that you can put your finger on it and say they've got a gene for alcoholism. Addiction gene kind of goes along with certain personalities. I think that you're inherited with, whether you like it or not. And some people just like food. I think that's my addiction gene, is food. But I'm not one to get just addicted on things. I don't have that kind of personality. But I do like food. And I do like certain kinds of food. That doesn't mean I have to have it every day. Every now and then, I'd like to have some more of that. But it's not like I go home every day and sit down and eat this food. Like alcoholics go home every day. On their way home, they pick up their 6-pack or their bottle of Jim Beam or whatever it is they're drinking and sit down and down it before they go to bed that night. I say, well, it helps me sleep. Well, I can knock you in the head and that'd help you sleep too, but does it mean it's good for you? So there's lots of ways to look at it. Now, some of the things that they noted in here was environment. Would you agree that environment's going to influence this one way or another? And these twins that they separated at birth, let's just say twins separated at birth, moved to 2 different parts of the world. So let's say one moved to Poto, Oklahoma, bless their soul. And another one moved to Michigan. That would be major different climates, wouldn't you say? Major different environments. As up further north you go, I don't think they think that much about drinking. It's probably open the fridge and there's a variety. You know what I'm saying? And you get to the Bible Belt of America, and some of us walk in somebody's house and open the fridge and see beer in there. But it's really not that uncommon. But let's say they got adopted by a family that's no drinking. Holy smokes, don't even think about drinking. And sometimes that in itself will drive somebody to drinking. Well, they told me I couldn't drink. So guess what I'm gonna go do? And then you got the twin up north that every time she opens the door, there's wine or beer or something in there. And she sits down at 12 years old and has a beer with her dad, which is illegal, but at the same time, as in her own household, she went to bed, dad limited her to 1 beer, that's all she could have. And when she grows up, it's not unusual for her to have a beer every now and then, but is she an alcoholic? Possibly not. Could she be an alcoholic? Could she be? Yeah, but at the same time, Dad said it was okay to have a beer, so no pressure there, right? There's one down in Oklahoma, by golly, my parents are not gonna tell me what to do, so I'm gonna go drink, I'm just gonna drink myself into an oblivion. And they liked it. Or it could be the other way around. Now, we highly recommend you not to drink. You won't ever see us drinking. You won't ever see alcohol in the refrigerator. So we'd rather you not drink. So to support mom and dad's wishes, because they approached it differently, they never drink and never really have a desire to drink even with their friends. So influence, direct influence, and the way influence is attached to somebody should make a huge difference. And where you live, whether it be the Bible Belt or who knows, there are places in the United States that's, I call them little Sodom and Gomorrahs. They're pretty bad. But I think there's so many things involved in alcoholism that we can't really put a finger on it. But I have to agree, Jennifer, the addictive personality gene, whether it be smoking, drinking, drugs, some people just have that personality. Who knows what they're gonna get addicted to, but I promise you they'll be addicted to something. It may not be anything that's gonna harm their body, but it could be things that harm their mind. So there's addiction, pornography addictions, probably one of the most rampant addictions out there today because of the free internet flowing out there. And could be one of the more lethal things out there. If you think about it, if you mess your mind up, you're messed up, aren't you? You mess your body up, yeah, it's messed up. A lot of the body has a chance to recover. Does the mind?
No, it takes a very,
I
very
mean,
long time, and then that's still never recovered.
That stuff's still there, isn't it? And that's really a hard one and a whole new can of worms if you get into that one.
Because they say once you're anorexic, you're always anorexic, because that mindset is still there, and
Yeah.
it's something that they have to fight.
I just need to be borderline just to slow my consumption down. Well, that's all part of the mesolimbic dopamine system. And basically what they're saying here is that these twins separated at birth, reared in different environments, and other studies involve the use of rats, all have indicated that the genes that code for one subtype of dopamine receptor in alcoholism. So they've located a gene, and what happened is they've used alcohol as the addictive agent. And I think that's why they use the gene as an alcohol gene. That's what they use for the addictive agent, but I think it's bigger than that. Other addictive drugs, including cocaine, morphine, amphetamines, are also known to activate dopaminergic pathways. So they went on and elaborated, kind of supported our theory on this about the personality. The next paragraph even talks about recent studies demonstrated that alcohol, amphetamines, cocaine, marijuana, and morphine promote the activity of dopaminergic neurons that arise from the midbrain and terminate in a particular location called the nucleus accumbens of the forebrain. Interestingly, nicotine also promotes the release of dopamine by axons that terminate in this very location. This suggests that the physiological mechanisms for nicotine addiction in smokers is similar to that for other abused drugs. Well, there was big news, wasn't it? I think we already had that one figured out. But that's where it's happening. That's what they've located. Now here's a danged if you do and danged if you don't. Drugs used to treat schizophrenia act as antagonists of the D2 subtype of dopamine receptor and can thus cause side effects resembling Parkinson's. So you're schizophrenic, we're going to give you a drug for schizophrenia and create Parkinson's. This suggests that the overactivity of the mesolimbic dopamine pathways contribute to schizophrenia, a concept that helps to explain why people with Parkinson's disease may develop symptoms of schizophrenia if treated with too much L-dopa. So if you have Parkinson's, you may turn schizo. If you have schizo and we treat you for that, you may develop Parkinson's. They found a direct correlation there.
And then people just think you're a hypochondriac.
Yeah, they're going to the doctor all the time, I need more drugs. Yeah. Hypochondriac. Well, they talk about in clinical application cocaine, and we've kind of talked about that quite a bit, where it plays its role as really a supplement for dopamine and how it acts in the brain. And people get the high off of it. It goes in and attaches dopamine receptors, but the body doesn't really recognize it enough to take it up, so it stays out there in the pathways and creates this euphoria feeling. So to get the same high over time, we have to add more to it. See what I'm saying? So we develop a tolerance to a certain level. So instead of breaking in your house and stealing the TV, now they're breaking in your car and stealing your entire car because they got to have a bigger addiction to get the same euphoria. So that's kind of where cocaine falls in. Norepinephrine is a neurotransmitter. We have talked about this one working with epinephrine. These two really act in the heart as excitatory in the heart. If you throw norepinephrine in skeletal muscle, it's not going to do a whole lot. You throw acetylcholine in the heart, it doesn't do a whole lot. You throw acetylcholine in skeletal muscle, we're excited. So a lot of times it depends on what the neurotransmitter is. they listed as it being involved in general behavioral arousal, which increase in cardiac output, increase in respiration will all be involved in that. 192, just in this little section of amino acids as neurotransmitters, this is why we've discovered so many neurotransmitters, because here we thought we just had some amino acids, but it's not the case. We see this amino acid acting as a neurotransmitter in this part of the body. So now instead of having 20 different kinds of neurotransmitters, now we have over 40 different kinds of neurotransmitters, and some are excitatory and some are inhibitory. Now to explain the reasoning there, and this should make sense, if we have biceps excited, what other muscle should be relaxed? Triceps. So for every opposing muscle, the other one should be doing the opposite. I mean, so we have to have, if acetylcholine's rushing to your biceps to pick something up, we have to send some neurotransmitter, whatever kind it may be, to the triceps to relax, or you're just going to have a stiff arm trying to pick something up. That's kind of ridiculous. So for every action, there's an equal and opposite reaction.
I feel like that's some sort of theory.
That'd be Newton's third law. I threw some physics at you now, easy. Throw some physics, and that's not a prerequisite to this course either, so jumping on that, don't want to scare you off. So just recognize some of the examples they have as far as excitatory and inhibitory. We already know that acetylcholine's considered excitatory, norepinephrine's considered excitatory, but we already know it depends on where those are found, what they're doing. Here's another one, excitatory neurotransmitter that's an amino acid category. Glutamic acid, aspartic acid, both listed as excitatory. Inhibitory neurotransmitters that fit in the amino acid category, glycine. Another one down at the bottom, GABA, gamma aminobutyric acid. GABA is considered inhibitory. So there's their examples that they give you in there. Just be familiar with those, recognize those examples. Now, polypeptide. A polypeptide as a neurotransmitter. The polypeptide example is one we've talked about before called cholecystokinin, CCK for short. This is used in the digestive system to tell the liver to produce bile. So bile is released from the gallbladder to go to the small intestine to help break up or emulsify fats. It takes fats and makes it into little bitty droplets, okay? But as a neurotransmitter, it's found in the brain that lays down long-term memory about food, whether you like this food or you dislike this food. Have you ever tasted a certain food and say, well, I don't ever want to eat that again, that was nasty? You remember that, don't you? You remember what it looks like, you remember the texture, you remember the taste, and you remember nasty. But at the same time, that's the best steak I've ever eaten. You think you remember that one? You think you want to go back and eat another one of those? That could be one of those addictive things, couldn't it? Sure was expensive, but I'll save up my money because it was worth it. Yeah, that's cholecystokinin. That's where it plays its role as a neurotransmitter and laying down long-term memory for food. Now, 194, we get into endogenous opioids. These are your natural analgesics, your natural painkillers. We have 3 different categories, which I don't know that there's a whole lot of difference in any of them. But they've identified dynorphins, endorphins, and enkephalins. These are 3 different kinds of natural painkillers. Would you agree some people probably put out more of this than others? Some people's pain threshold's higher, so I think it's directly related to these endorphins. Now, for a long time, they have thought that these endorphins is what gives a person an exercise high or a runner's high. Who in here likes to exercise and feel like they need to every so often, or they go into withdrawal symptoms? My wife's like that. In fact, she said last night before she went to bed, she said, I hadn't exercised in 2 days. I thought, man, I think I'll sleep somewhere else. So she's going to be meaner than a snake until she exercises again. And she kind of gets that way. She says she turns into a pumpkin after 9 o'clock, kind of a zombie. That's when she turns mean, after 9 o'clock. I told her last night, I told you all this all the time, how mean she was, and she said, they don't believe you do this. I said, no, they think I'm an idiot. that she has to be pretty nice to put up with me. I think that pumpkin stage is self-defense at night when we're both tired. But she does like to exercise, and if you give her time to exercise, there's a better mood there, and everything's better for the whole family if mama's happy. If you didn't know that, you will learn that. You know that, don't you, Jed? If mama's happy, the whole family has the opportunity to be happy. If mama's not happy, the whole family must get out of her way and leave her alone. Because it's not, is it that way at your house? Okay. I think it's the endorphins and kephalins. That's what I think. And now, they did a little study though. They're always doing studies on this. And they did two different studies. They did a human study of this exercise, and they found a drug called naloxone. And naloxone, if you're familiar with drugs at all, they have any anesthesiologist will carry in their pocket. They'll have what's called a reversal drug. There's different varieties. Naloxone is one of those. So if they put somebody under and it's going south and this person, they'll use a reversal drug to stop whatever they did to get back to ground zero. Have you ever heard of this drug? It's out there. It's a life-saving drug, I'm telling you. Because a person's never been put under with anesthetic, and they don't know exactly how they're going to respond, and they give them the normal amount for body weight, and their body's allergic to it or doesn't deal with it correctly, then it would kill them in a normal situation. These reversal drugs save lives every day. And most of us don't even hear about it because they're not going to say anything. They're just going to give them a shot, bring them back. Oh, we're good. We're good. They're alive. So that's what naloxone is. So naloxone was given to a person that gets this exercise high. In theory, the naloxone should have blocked painkillers. In all the other studies, naloxone blocked painkillers. For instance, the other study was they observed a rat in labor. Okay, so this rat is in labor having little rats. Are those ratlings? I'm not sure what little rats are called, but little rats. Needless to say, the rat seemed to be in pain. I guess they could see gruesome facial features while this rat was in labor. So while in labor, they give the rat a shot of naloxone. This is mean, isn't it? Yeah. And they seem to observe that the rat was in more pain. This is one mean rat now. This rat's blaming everybody for her pain now. So through that observation, they theorized that naloxone blocked the natural painkillers that the rat's body should be producing, and probably was. And they're going to apply it to humans. Now, no researcher in the right mind would give a woman in labor a shot of naloxone if they want to live. So they just said, well, same painkillers are given off during the runner's high. We'll just give it to some runner and see, and they can tell us what happened. At the end of the jog or the exercise, they will still hire a kite on their own endorphins. So their conclusion is that either naloxone does not affect endorphins in humans, or they're getting a runner's high from something we don't know about so far. So there's the research. What do we really know from that? Nothing. Absolutely nothing. It's interesting,
paying for all
wasn't
this
it?
research?
Do what?
So who's paying for all this research?
Well, I think
Tax
Texas
dollars?
A&M's doing most of this. Bunch of Aggies doing research. You don't get a lot of good results. So I have no idea, but I heard that once, so I thought that's pretty good. Now they tell you about all this. They're in page 1 on 194 in the right-hand column. I'm not going to read it to you, but you can read through it. Neuropeptide Y. Neuropeptide Y is the most abundant neuropeptide in the brain. It has been shown to have a variety of physiological effects, including a role in response to stress. Well, that maybe stress, because society is so stressed, is why it's the most abundant in the body. Does that make sense? In the regulation of circadian rhythms and in the control of the cardiovascular system. Here's what you need to know about it. Neuropeptide Y is a powerful stimulator of appetite. Neuropeptide Y. It says when injected into a rat's brain, it can cause the rat to eat until it becomes obese. Conversely, inhibitors of neuropeptide Y that are injected into the brain inhibit eating. Guess what that inhibitor would be? We learned it at the beginning of the endocrine chapter, and fat produces it. You remember the name of it? Read down 2 sentences, it's right there.
Starts with a C.
Leptin. The stuff we said was bogus unless we exercised and burned the fat. Yeah. Leptin injected in the rat's brain stopped this eating to obesity. So it obviously plays a role in the satiety factor secreted by adipose tissue. Leptin suppresses appetite by acting at least in part to inhibit increased neuropeptide Y.
So do they sell leptin shots for people that want to lose weight?
No, but you can, there are some pills on the market, everything's in a pill, called leptoprin or leptopril. There's 2 different variations. You probably have seen advertisements on TV about leptin. I haven't seen them lately, but there was a time in which they said, oh, you don't need to take this pill unless you're serious about losing 30 to 40 pounds. It's like $100 a bottle, which for diet pills is probably not that bad. And but you don't have to do anything to take the pill, and that's what everybody wants, right? You don't have to exercise, you don't have to do anything different. You can eat whatever you're going to eat, but according to the pill, you're not going to want to eat as much as you normally would eat. So leptopril or leptoprin. Now whether it's still out there today, I don't know. They may have shoved it off the market after it killed some people, like the fen-phen products. So, and there's still variations of fen-phen products out there. I'll just give you a heed of warning here. Anything that comes in a pill form that is affecting appetite or diet is probably not healthy for your entire body. There are serious side effects. I know there's kind of a local thing going around. There's an appetite suppressant, and then they give you a small water pill. Well, the water pill, yeah, you're going to lose immediate water because you're going to pee it all out. Okay, so you're going to have to drink more to replace it. But you're going to lose weight immediately. It looks like, man, this program is awesome. It's working. But then the other pill suppresses your appetite, and it does many other things. And it is a spin-off of the old fen-phen product that causes heart problems in people. In fact, it killed people. So
What is that
those, I don't know what the name of that is. I do not. But just be aware of those things, and it's best to develop your own way of losing weight, which is more of a mind control, slow consumption, eat smaller amounts more often instead of large amounts 3 times a day. Those are just moderation things that'll put you in a better habit. Our lifestyle creates bad habits for us because we're not where we can snack a little bit all the time, and that the body's made to eat that way. It's made to eat a little bit along all the time. Can you imagine where your glucose level and insulin levels would be if we consumed a little bit all the time? They'd be right here. Instead, we're like this. You wonder why we have so many diabetic problems. We're all over the board, and we create that ourselves. And most of the time, our eating habits are driving 75 instead of 65, eating a Big Mac and drinking pop, which is none of that's really good for you. Every now and then, maybe we have a craving for it, but to just sit down and eat the good foods, or occasionally I'll have students come in here and they'll have a bag of carrots, eating carrots. That's pretty good stuff. I mean, I can sit there and eat carrots, but am I full when I get done eating those carrots? It's like, bring me another bag. Bring me a different vegetable. I can eat 5 apples and slap somebody. What you do with my food? Apples don't fill you up either, but they're good for you. So, it's changing habits is the best way of losing weight. And it's a mindset. Sometimes you gotta be stubborn as a mule to get it done. Just like breaking addictions, smoking. I know people that smoke, and my grandfather smoked cigars the entire time I knew him until right up to the end. And he had a little cancer come up on his lip. Doctor said, we can fix that one. We may not be able to fix the next one. You better give up the cigars. The day he died, there was still a whole box of Roy Tan cigars in his closet. And it stayed there till the day my grandmother died, when I finally threw them out. But he was stubborn enough. he did whatever he wanted to do. If he wanted to smoke a cigar, smoke a cigar. When that guy told him about cancer, he quit. But guess what got him in the end? Cancer. Yeah, it's the darts we throw when we're young that hit something when we're old. That's what gets us. So when you think you snuck by something, just like President Clinton said he didn't inhale that marijuana cigarette, chances are he did. That may get him somewhere down. He thinks he got by with it, it'll come back to haunt you. Decisions we make at one point usually catch us at some other point. Moving on, the endocannabinoids as neurotransmitters. These are very similar to THC in marijuana, or from marijuana. Endocannabinoids thereby modify the actions of a number of other neurotransmitters in the brain. If you take enough of this stuff, I guess you'll have less worry. It's kind of how marijuana affects you, isn't it? Oh, that's cool. Who knows? It's a pretty interesting little deal to read through there. I might pick up a few things from that. Nitric oxide and carbon monoxide as neurotransmitters. Now, nitric oxide, not to be confused with nitrous oxide, which is laughing gas. Nitric oxide is actually produced by endothelial cells in the lining of your vessels, and it causes vasodilation. So this is a normal thing that happens in the body when we need it to happen in the body. So we don't have to worry about this at all. Now, carbon monoxide as neurotransmitters, your red blood cells love carbon monoxide. Now, they love carbon monoxide better than any other gas, better than oxygen, better than carbon dioxide, better than anything. It loves carbon monoxide. And we actually use it as a neurotransmitter in the body. Now, they list nitric oxide down here being a vasodilator, and they talk about several different things there. And then carbon monoxide on the next page says it may function as a neurotransmitter. Certain neurons, including those of the cerebellum and olfactory epithelium, have been shown to produce carbon monoxide. So we're not exactly sure what effects it has, but we see parts of the body or parts of the brain actually producing it. There's got to be a reason why they need it produced. But that's just, again, that's part of the young science physiology. We don't have our finger on it yet, but we found it. But one of these days we may figure out what the purpose is. They do think it may actually cause some dilation in some places, but that's just, right now, it's kind of a theory thrown out there. Back to the nitric oxide, when they learned this concept and saw what nitric oxide did, they started developing a drug. And this drug was supposedly being developed as a heart drug, because kind of like nitroglycerin, if somebody's having a heart attack and they take nitroglycerin, they get massive vasodilation. It may prevent the massive damage that could come from that heart attack, and at least buy enough time to get the major problems fixed. So, another company is working on a similarity to nitroglycerin, and they get to working on this drug, and they see that it's not only having effects on the heart, but it's having effects all over the body. And even in places they think, well, we can sell it better here than we can here. So that's where Viagra come out. And Viagra was studied and researched as a heart medication, and they found it did wonderful things in other places. And so, boy, well, this will sell. So they went to the money route instead of the health route. And now they tell you it could kill you if your heart's not strong.
So I was gonna say, so if you wanted to say, oh no, I'm using it for my heart.
You actually can say that now. It has now been approved for certain heart conditions. So after how many years, I have no idea how many years it's been out on the market, but after all these years it's been out on the market, behind the scenes they're applying it to heart issues, and now FDA approval has been approved for certain heart conditions with Viagra.
Do they change the name?
Nope, don't think so. It'd be embarrassing to take that if you really had heart conditions.
That's what I was saying.
I'm taking it from my heart. Yeah, all right. Okay.
It's also an excuse to, never mind.
Never mind. Let's never mind that one. But anyway, about the time Viagra was hitting the market, there was another drug hitting the market that was put out by Pfizer Medicine. I believe it was Pfizer. I may be off on that, but it was a cattle drug called ivermectin. And if any of y'all's familiar with cattle, ivermectin is a pour-on wormer. It's been a classical wormer for years and works really well. You get a little fly control, you get most of the worms taken care of, and the whole shebang. So this guy I know he plays the stock market all the time, so he knew that ivermectin's fixing to hit the stock market, so he buys stock in that company, thinking this is gonna be a home run. Oh, it was a home run, all right. Viagra's the one that hit the market that screamed the profit margin way up there. He did all right with ivermectin, but he invested in ivermectin, but Viagra made him a wealthy man, let's put it that way. He dropped 10 grand and come back with over 100 grand within just a few months, because Viagra and ivermectin hit the market at the same time from the same company. Now that's luck. If I did that, Viagra would have been headed the other direction and said, well, that was a flop. So my 10 grand, I might have got back $1,000 out of it. That's the way I invest. That's why I'm still teaching, of course. 196, we have spatial summation, temporal summation. A spatial summation occurs as a result of convergence of presynaptic axon terminals, up to 1,000 in some cases, on the dendrites and cell body of postsynaptic neurons. So convergence of presynaptic axon terminals on dendrites and cell bodies of postsynaptic. So we're coming from presynaptic to postsynaptic. We're spatial, we're covering a large area, bringing it in. Temporal summation is successive activity of presynaptic axon terminal causing successive waves. This is an EPSP, basically. We have small, not action potentials, but small summations that's firing off a neurotransmitter that could summate to an action potential, and that's temporal summation. Over on 197, we see long-term potentiation. Long-term potentiation is the ability to lay down long-term memory. That's the bottom line. Now, how best can that happen? What would be the easiest way to lay down long-term memory?
While you're sleeping.
While you're sleeping? I've read some things on that. In fact, when I was in high school, I actually read the notes and taped it and played the tape while I slept. I saw no significant difference in results in that test. So I went back to studying like he should do. It didn't increase it any at all. But there are some neurotransmitters that's built while you're sleeping that's going to help this process. I think serotonin plays a role in that because there's some vasodilation involved with serotonin. But long-term potentiation is best laid down in a combination of things. Number one, are you most likely to remember something if it's something you're interested in?
Yes.
That's why y'all have difficulty with this class? Is that what you're saying?
Aww.
That was so wrong.
I love science, are you joking?
Bingo. It's always, if I'm interested in something, that I can remember a lot more about it. So interest in something fires off more neurons, which means there's more neurotransmitter involved. More neurons, more neurotransmitter, more long-term memory, okay? And if you want to learn something that you really have no interest, then you have to become repetitive with it. Repetitive. Work in a whirlpool example here before they left us all hanging. Work an assembly line. You do that enough, you may not like it, but you can do it blindfold, backwards, upside down, in your sleep. Because you've done it so many times, you know exactly what you have to do. And even to the point you do it unconscious. You just go through the motions. That's long-term potentiation. So repeating yourself over and over, that's why we say to start studying a week before. And if time you go over it several times, it'll start laying down some long-term memory. If you're interested in it, you can probably learn it faster. And there's topics in here that probably interest you more than other topics, would you agree? So you do better on those tests than you would tests of things that I wish we could get out of this, I don't really like this topic. Some of y'all's thinking that about the class. I wish we could get out of this, I don't really like this class. So. All right, that finishes chapter 7. Takes over to chapter 8. Chapter 8 correlates a lot with our lab coming up on Monday. And I want to cover I want to at least cover another 5 or 6 minutes of this to help identify some things we're doing in lab as well. The beginning of this basically tells us about the central nervous system containing association neurons, where sensory neurons are bringing information into it, motor neurons are taking impulses away from it, and that it is our central nervous system that sees, it hears, it basically does all the things we think our eyes and ears and taste buds are doing. It does that. Those are just bringing information to it. So the brain is doing it all. Those central receptors are just bringing information to it. So everybody could perceive something different. We could have 3 people watching the same thing and get slightly different descriptions of what's going on, couldn't we? Because everybody's brain perceives a little different. Everybody's a little different when it comes to that. So the capable of it says the central nervous system of all vertebrates are capable of at least rudimentary forms of learning and memory. Rudimentary, it doesn't get much lower than that, so y'all are even capable of rudimentary forms. This capability, most highly developed in the human brain, permits behavior to be modified by experience. That is the #1 way of learning. Behavior modified by experience is actually a definition of learning. It may not be the only definition of learning, but if your mama told you not to put your hand on that hot stove, and you thought, okay, mama, as soon as she walks away, you go, and you sizzle it, you just modified your behavior by learning the hard way, didn't you? Now, most of us learn quite well the hard way, unfortunately. Perceptions, learning, memory, emotions, and perhaps even self-awareness that forms the basis of consciousness are all creations of the brain. Some people tend to be a little more imaginative than others, because you were there and you saw what happened, and what they're saying is a little stretched from really what happened according to your creations of the brain. See? Don't you love little kids' imaginations? I mean, what really happened, and you was there as the parent, is way out there in left field, in their opinion. So, I love it when my 6-year-old's correcting my 4-year-old, and neither one of them's even close to being right. So, how big is your brain? 3 to 3.5 pounds. Head feeling heavy today? Maybe it's a little bigger than you think. 3 to 3.5 pounds. It receives about 15% of total blood flow to the body per minute. This high rate of blood flow is a consequence of high metabolic requirements of the brain. It is not, as Aristotle believed. Aristotle thought the purpose of the brain was to cool the blood. Does that make sense? Where do you lose heat from your body?
Your head.
Top of your head. I mean, you got to give Aristotle a little credit here. This is by observation. He didn't have technology to really say what the brain's done. He's a pretty sharp character in his day. To observe, you're losing heat off the top of your head. Man, you're a hothead. Purpose of your brain, it's getting a lot of blood. We're dissipating heat. That's what it's doing. Well, we laugh at him now, but the guy was sharp. We had to start somewhere, didn't we? So we started with his observations. Now, this doesn't talk about Sir Charles Sherrington, but Sir Charles Sherrington identified the brain. Once he looked at it, he called it the Great Raveled Knot. And, you know, if you think about it, if our convolutions are different than the sheep and much deeper, and we have these high gyri and low sulci and deep convolutions, and you could see where he could kind of identify a great raveled knot there. So he went on to say that we will not ever completely understand the brain, because we're trying to understand the brain with a brain in which we don't understand. Now that's a sharp statement, isn't it? Kind of spinning a circle there, but he's right. I mean, we're not going to ever totally understand it. So starting on 206, the cerebrum, we know it's the largest part of the brain. We know it has right and left hemispheres connected by corpus callosum. This is all from lab, right? We know these convolutions increase surface area. The convolutions are made of the low sulci and the high gyri. That increased surface area should make us have more surface area for intelligence, for conscious thinking, for laying down memory, whatever it may be. It increases surface area. So your 4 lobes are your frontal, parietal, along here through here, temporal on the sides and occipital on the back, and we identified occipital for vision, temporal for hearing, frontal for personality, language, and some memory. What would we say about the parietal? What's our two big terms we're looking for parietal? And somaesthetic. Somatosensory is the big one on the study guide. So I don't have time today, unfortunately, to tell you a couple of stories that goes along with this, but mark in your notes, if you will, the story of Gage. And we will start with that story when we come back on Monday. And we'll continue through, of course, Monday we have a lab test, correct?
No,
Tuesday for y'all, I'm sorry. Yeah, Tuesday for y'all, we have a lab test, and we'll be heading our way on through this chapter. This is a fairly long chapter. It'll take another couple class periods, and then we'll be in chapter 9.